Hello friends, welcome back to Dr. Jackie's Academy. In today's lecture, I will discuss a very important topic which will cover a large number of topics. Actually, you can say that is hypersensitivity reactions. Okay, so these are also called as allergic reactions. You know, these are very common things in our even daily life. So, but you have to understand what are the different kind of hypersensitivity reactions. So, let's start. So in this video, I will discuss four types of hypersensitivities, that is type 1 hypersensitivity, type 2 hypersensitivity, type 3 and type 4. All these hypersensitivity, they are denoted by the Roman numerals. So first of all, we will define what are the hypersensitivity reactions. If you know, hyper means excessive, sensitivity means the person is responsiveness. The responsiveness of the person has become much more as compared to a normal person. So we also call these as the allergic reactions. And as I told, what happens is that the immune response becomes highly sensitive. So it responds to allergen in an excessive manner, hypersensitive manner, in a more sensitive manner. So actually there is an issue related to the immune system. So if the immune system is overactivated, then it will lead to undesirable side effects in the body. And if we see type 1, 2 and 3, all these hypersensitivity reactions are because of the antibodies. These are antibody-mediated hypersensitivity. But the fourth one, type 4, is actually a cell-mediated hypersensitivity. Okay, so we will discuss these hypersensitivity reactions one by one. First of all, coming down to type 1 hypersensitivity reaction. So the typical characteristic features of these hypersensitivity reactions include involvement of IgE antibodies, a very important factor. Second, involvement of mast cells, basophils and eosinophils, particularly the mast cells. Then what are the examples of type 1 hypersensitivity reaction? An example is the bronchial asthma. The details of bronchial asthma you can see in a link which is given in the description section. Okay. So now we will study what are the different steps involved in the type 1 hypersensitivity reaction. So we can divide hypersensitivity reactions into two stages. First is the first exposure. That means when the person is exposed to antigen for the first time, and subsequent exposures when the person is exposed to same antigen again and again. But what happens in the first exposure? Let's say this is an allergen, some allergic agent that has come inside the body. So first of all, this allergen will encounter the cells of our body which are called as antigen presenting cells, APC. So the interaction of APC with the allergen will lead to the activation of helper T cells, CD4 plus T cells in our body. So once these helper T cells are activated, there is a release of cytokines interleukin 5 from the helper T cells. These interleukin 5 helps in the activation of B cells, which ultimately produce the IgE antibodies. Okay. Moreover, these cytokines help in the recruitment of mast cells. Now these two will interact. These are the mast cells. These will interact so that mast cells are coated with IgE. These are mast cells coated with the IgE antibodies. So this is the first thing which happens in the type 1 hypersensitivity reactions in the first exposure. That is, the mast cells, they are coated with the IgE antibodies. Now they are present in our body. So now, what will happen if the same antigen come again, subsequent exposures? Same allergen comes, now it encounters with the mast cells coated with IgE. It will lead to the cross-linking of these antibodies. This allergen will cross-link these antibodies. Cross-linking of antibodies. And cross-linking will lead to the activation of mast cells. Mast cells will respond by degranulating. The granules, they release their material, they release the primary mediators from the granules, and they are responsible for the early phase reactions which start within 10 to 20 minutes. Okay, early phase reactions. But simultaneously, the activation of mast cell is also producing a secondary mediators. Actually, there is a synthesis of this one. So there is a difference, release of preformed material and synthesis of new mediators. The new ones, they are called as secondary mediators, and it will take certain period of time to synthesize new material. So this is responsible for the late phase reactions, typically after 4 hours. So we can explain with the help of a written method. Early phase reactions, they start within 5 to 30 minutes. Okay. So there is a release of preformed mediators called as primary mediators from the mast cells. Examples: histamine is mainly serotonin, heparin. And what are the effects? Histamine will produce number of effects. Number one, it will produce the vasodilation. It will increase the vascular permeability, and it will produce the spasm of the smooth muscle. That means contraction of the smooth muscles. And the most prominent effect is on the bronchi. It will constrict the bronchi, bronchoconstriction. So vasodilation, increase in permeability, and bronchoconstriction are the typical effect of histamine, which happens in the early phase reactions. And these reactions subside within 60 minutes. So short term effect. Late phase reactions. So they start after 2 to 8 hours after antigen exposure. Symptoms persist for several days. So you can differentiate between the early and late. Several days, and last it was 60 minutes. 2 to 8 hours, and the previous one it was 5 to 30 minutes. So now there is the synthesis of the inflammatory mediators. In the previous one it was the release of mediators. Here is a synthesis of inflammatory mediators from the mast cells. From where? What is the source? Arachidonic acid, which is released from the mast cells. So it produces number of mediators. The most important are the leukotrienes. Examples of leukotrienes: LTB4, C4, D4, and E4. Then there are prostaglandins. Then there are cytokines. Then this C4, D4, and E4. Earlier they were also called as SRSE. That means slow reacting substances of anaphylaxis. Why? Because as I told, type 1 hypersensitivity can be anaphylaxis also. I will tell later on. So if it is anaphylaxis, they come later. Okay, primary mediators come first, then secondary mediators. So that is why, because they come later, so they are called as slow reacting substances of anaphylaxis. But it is an older term. Now they are called as 69 leukotrienes. So what are the types and symptoms of type 1 hypersensitivity reaction? It can be local reactions. Local reactions mean they are localized to certain organs, like it may be to the skin. So there may be urticaria. It may be to the lungs, then it may be the asthma. But there can be systemic reactions, whole body is involved. Then we use the word anaphylaxis. So anaphylaxis is basically a type 1 hypersensitivity reaction in which widespread involvement is there. So widespread symptoms. So what are the symptoms? Vasodilation. If excessive vasodilation is there, then BP will reduce, hypotension. So blood pressure is reduced. So blood is not flowing to all the organs. So there is a decreased tissue perfusion, and ultimately it will produce this circulatory shock. Circulatory shock means enough blood is not there to circulate the whole body. So because vasodilation, excessive vasodilation is there. Then bronchoconstriction is there, dyspnea, very important feature. Vomiting, diarrhea, abdominal cramps, these can also be very serious. And sometimes this anaphylaxis is very serious, it can be life-threatening. One example I can give: penicillin. If penicillin is not tolerated by the person, if person is hypersensitive to penicillin, so they may develop the anaphylaxis reactions. So this is all about the type 1 hypersensitivity reactions. Now I will discuss about the type 2 hypersensitivity reactions. So now what happens? What is the characteristic feature? You have to identify the typical characteristic features of all these hypersensitivity. Number, as I told, in type 1, there is IgE and mast cells. Okay, coating of mast cell with IgE. So in this type 2, you have to remember that the antigens are very similar to the normal cells. That means something is not very different from the normal cells. It is very similar to the normal cells. So what I am saying, antibodies produce destruction of the cell or components which are very similar to the normal cell. You will come to know the definition of this one when I will explain the examples. Like, let's say whenever we want to give some blood from one to another person, where you are donating a blood, so there is always a testing of A, B, O group and the positive and negative Rn positive. So Rh positive. So if in the blood this kind of matching is not done, so if you give the blood to a recipient, then the RBC will be destroyed. Why this will be destroyed? Because of the activation of type 2 hypersensitivity. So that is the one. Destruction of RBC due to the non-matching or incompatibility of ABO group or the Rh factor. So here you can see the blood cells are not very different from the normal cells, very similar, but obviously some differences. So these can be two type 2 hypersensitivity. Number one, you have to see the word I am saying. Antibody-mediated cellular dysfunction. That means antibodies are producing some dysfunctioning of the cell. Okay. Now see the second term. Antibody-dependent complement-mediated cell destruction. It means here antibody itself was doing, but in this condition antibody is doing indirectly. Antibody is activating the complement system. The complement system is ultimately producing the cell destruction. You will come to know. I will explain with the help of the chart. So first this one, antibody-mediated cellular dysfunction. So let's say I am giving an example. You know, acetylcholine is an important neurotransmitter in our body. It acts on the nicotinic receptors. I have specifically written the NM receptors. NM receptors are present on the skeletal muscles, which are responsible for the muscle contraction. So you can say they are present on the neuromuscular junction, motor end plate or the skeletal muscle. So this is a normal thing. Now, what happens in the type 2 hypersensitivity? Now antibodies are produced. These antibodies, they target these nicotinic receptors, body's own nicotinic receptors. Okay. So as a result, these nicotinic receptors, they become dysfunctional, non-functional. So if they become non-functional, how acetylcholine will produce the muscle contraction? So that means it will not take place. So no muscle contraction. So this leads to a disease which is called as myasthenia gravis, paralysis of the muscles, weakening of the muscles. Okay. So this is the myasthenia gravis. An example which comes under the category of antibody-mediated cellular dysfunction. Coming down to the second type of type 2. Here, antibody-dependent complement-mediated. That means antibody will be activating the complement. This complement will produce the cell destruction. I will explain. So example, as I told, destruction of blood cells due to mismatching. Let's say this is the mismatched blood, foreign blood cells. So here are the antigens which are not very similar, which are different from our cells. So it will lead to production of antibodies. Let's say these antibodies are produced. So these antibodies, they will attack on these antigens. Okay, but they will not destroy it, these antibodies. Rather, this interaction will lead to activation of complement system. There are complement system means there are many proteins present in the blood. They are circulating. So I'm just telling one of the complement system. This is called as C59, and we are writing a line over it. So what is the meaning of this one? This is actually a membrane attack complex. That means there C9 means C5, 6, 7, 8 and 9. These complement factors, they join with one another to form a complex which is called as membrane attack complex. And when we write this line, it means it is activated one. So that means as the name indicates, membrane attack, it will attack the membrane of this one, this will attack on this membrane, and it will lead to the cell lysis. So this is the end of type 2 hypersensitivity reaction. Now I am discussing very important hypersensitivity reaction which is called as type 3 hypersensitivity. So now, what is the typical feature of this one? If you have to you underline this type 3, so underline is that there is formation of antigen antibody complex. So this complex is called as immune complex. This complex is formed, and what will happen, where this complex will go? This complex is deposited in the tissues. Okay. After the deposition, there is initiation of inflammation, and inflammation is initiated, then it will produce the damaging effect on the tissues. Okay, so I will explain this one. This can happen in two ways. One is the systemic immune complex disease. That means here I have used the word immune complex, and I have written the word systemic. Systemic means to the whole body, in the blood. Okay, so that means this immune complex which is formed, it is present in the blood, it is circulating. Okay, so this is called a systemic immune complex disease. It is also called a serum sickness type. I will explain this one. Second, instead of circulating in the blood, instead of going to the whole body, this complex may be deposited to some tissue, some local tissue. It is not going into the blood, but some local tissue. So this is called as Arthus reaction. So either immune complex to the whole body or immune complex to certain tissue only. So we will explain these one by one. So systemic immune complex disease, which is also called as serum sickness type. So we have to divide this whole reaction into three main steps. First is the, as I told, formation of immune complex in the blood. Here this is the important word, in the blood. And it will take approximately 5 days. Then this immune complex which is in the blood, and then it will move from the blood and it will be deposited in some tissues. Let's say it may go into the kidneys, it may go into the liver, it may go into the joints also. Then after the deposition, there is initiation of inflammation in the tissues, and it will take approximately 10 days after entry of the antigen. And it is called as serum sickness type. Why it is called as serum sickness? So if you understand the name serum, you understand it is a way of giving the passive immune. It is a type of a passive immunization. When you take out the serum, which is containing antibody, you give to some person so that immune system is activated. Passive immunization. But that serum may contain certain foreign antigens and may make the person sick. That is called as serum sickness type. So this is what I am writing. So when you administer the antibody-rich serum, which is a part of passive immunization, may produce typical symptoms of type 3 hypersensitivity reaction. So I will explain this one, these three steps. Formation of immune complex. Antigen enters in the blood. It will lead to the formation of antibody within 5 days. Antigen-antibody complex will be formed. Now, if this complex is formed in the blood, what will happen? Number one, if this complex is small size, then it will escape the phagocytosis. RBC will not be able to recognize this one. And what will happen? It will circulate in the blood. But if this complex is large enough, then macrophages, they will recognize and they will remove it. So it will not circulate. So second step, deposition in the tissues. So immune complex travels in the blood. This moves out of the blood vessels and deposited in the tissues like kidney, joints and skin. Inflammatory reactions. So now what will happen? If it goes into the tissues, this antigen-antibody complex will activate the complement system. This complement system will release chemotactic factor. You know, if the chemotactic factor is released, it will recruit WBC, neutrophil aggregation. Neutrophils will release number of enzymes like lysosomal enzyme, free radical, which will produce the tissue damage. Moreover, this antigen-antibody complex will release vasoactive amines like histamine, heparin. Okay. So they produce vasodilation and edema, which produces the tissue damage. Then this antigen-antibody may produce aggregation of the platelets. If the platelets they start aggregating, they can block small capillaries. So they can lead to micro means small, thrombi means aggregation of platelets, so that blood is not moving in the capillaries. So microthrombi, which will produce the ischemia, and ischemia, you know, it produces the tissue damage. So you can say widespread effect of this kind of a deposition. So now, what are the clinical manifestations? So clinical manifestations They obviously depend upon type of the tissue or the organ which is involved. Mostly the symptoms include fever, as I told, serum sickness, fever will be there, involvement of skin urticaria, and if it has gone into the joints, it will produce the arthralgia, that is the joint pain. Or another side is that it will go into the renal tissue, okay, and it can damage the glomeruli to produce the proteinuria. That means if the glomeruli are damaged, proteins they start coming out from the blood into the urine, proteinuria. It is a sign of the renal injury. Then we can have the localized form of the immune complex reaction, which is called as Arthus reaction. So earlier I told serum sickness, this is the Arthus reaction. When the Arthus reaction will take place? Now, first I am telling the definition. When the immune complex is formed and deposited at the point of entry of antigen, so it is not going into the blood, but wherever it starts to enter inside the body, it will be deposited at that site. Now, what is the important issue? Why this kind of thing is happening? Because that person has already preformed antibodies against the antigen. So, if the preformed antigens are present, then if antigen tries to enter, these antibodies they attack on those antigens. So that complex will be deposited at the point of entry. It will, so that means antigens will not be able to enter inside the body, inside the tissue. So this is called as, and so what I was telling, that immune complex is deposited at the point of entry. But the reactions are almost same. That means same kind of inflammatory reactions are initiated in the systemic one, but they are localized. So I'm just explaining with the help of this flow chart. Entry of antigen, preformed antibodies bind with incoming antigens, formation of antigen antibody complex at the site of entry, deposition, and complement system activation, neutrophil activation, and tissue damage, local injury. Coming down to the fourth type of the hypersensitivity. Now, as I told, this is different from type 1, 2 and 3 because it is cell-mediated. Earlier they were antibody-mediated. So, cell-mediated means it involves the CD4 plus cells and CD8 plus T cells. CD4 they are called as helper T cells, they are called as cytotoxic or the killer T cells. So these reactions are also called as delayed type hypersensitivity, DTH. Reason is because in comparison to antibody reactions, these are relatively slower process. Okay, so they take certain period of time, 2 to 3 days after the antigen entry. So I will give some examples of type 4 hypersensitivity, like graft rejection, organ rejection. Let's say you have transplanted one organ from one person to another person. If that organ is not matching, then it is rejected, and that is rejected by type 4 hypersensitivity. Then tumor. If there is a tumor, then immunity is developed against that one, tries to develop the immunity, that is basically a type 4. Then if you carry out a Mantox test, which is basically done to check the presence of tuberculosis, for the detection of mycobacterial tuberculosis, if the positive Mantox test comes, it means there is a type 4 hypersensitivity. So what are the steps involved in type 4 hypersensitivity? I will explain with the help of this flowchart, with the help of a figure. Let's say this is an antigen. Okay. And as I told, the first encounter of the antigen is with the antigen presenting cells, these cells. So these are antigen presenting cells, these two interact. Okay. So and this interaction will comes in, you can say, it will expose or it will make the, this will come into the play, that is MHC. MHC is the major histocompatibility complex. This of class 2, that is more important in this condition. MHC class 2. Now with the help of this antigen and MHC class 2, there is a activation of CD4 T cells, helper T cells are activated. And what will lead to? It will lead to release of cytokine which is called as interleukin 2. Now very importantly, this interleukin 2 itself act on these cells. So that means something which is released is acting on the same cell. When this kind of a system is acting, this kind of a signal is called as autocrine signaling. Autocrine means something is released by the cell and that again acts on that cell to stimulate it. So autocrine signaling is there. Ultimately, this kind of a thing cycling will make these cells active. That means CD4 cells are activated. So now once these cells are activated, they themselves release certain cytokines called as TNF alpha and moreover interferon gamma. TNF alpha and interferon gamma, these act to activate and recruit macrophages. So you have to remember that there is a positive interaction between these T cells and macrophages. So what is happening is that T cells are recruiting macrophages through these, and this is the, when I am saying this is the stimulation. Macrophages in turn they release cytokines. They also produce the stimulation. So there is a positive interaction between these two. So slowly and slowly these are activated, recruitment of macrophages and T cells. So this is previous was with the help of a figure. This is in a written form. Antigen activates antigen presenting cell. Antigen presented to CD4 cells in the presence of MS class 2. CD cells release interleukin 2, which acts in autocrine manner to activate the T cells. T cells secrete TNF alpha to activate or recruit macrophages, and macrophages and these two are activated in a positive feedback manner. So this is what I wanted to discuss with you. 4 important type of hypersensitivity reactions, type 1, 2, 3 and 4. In upcoming video I will discuss more things about the immune system, that is immune response, innate immunity, acquired immunity, cellular immunity and the humoral immunity. Thank you.